All right, so I was basically making the classic mistake of the address not being the exact address that I was putting in. So I just always got to make sure that the address that I'm looking at is the correct address. But now it seems to be working. So let's see. So there was no problem with my code, pretty much. If we take a look at the amount of, so for example, over here we have staked Olympus, and this address has 94,000 of staked Olympus. Oh, actually, it's not even showing up. But let me just double check that this address is the correct one. Um, this is getting a little bit annoying. Not gonna lie. Okay, now that I'm taking a look at this address, it is returning this much, which I mean, I guess ballpark-wise maybe is correct. 94,000. This is not correct. This is 94,000. This is 159,000 of staked Olympus. Let's see what the actual contract itself on Etherscan returns. This is actually a pretty good sanity check. So if you go here on contract, read contract, this is the same contract, which is staked Olympus. Contract, read contract, and then you query this. It'll give you the same amounts that I have here, which is 159, 83495. So this is the amount of what's it called? The stake Olympus that this account does seem to have. So I don't really know why. Like, it could be a problem with the holders section of this token, that it reports it wrong, because clearly this is wrong, because the actual contract itself is returning something else. Um, let's try Olympus DAO staking contract's address. Maybe that'll be a little bit different. This should have like some humongous amount of um, coins. So, oh, promise rejection. We probably ran into another overflow or something. Yeah, we did run into an overflow. God damn. So much money is in there. Alright, so let's go and figure out what the problem is. So we have this. No, sorry, I'm looking at the wrong place. Balance page from big number. There we go. We have from big number, and then we multiply by some significant digits, and then we divide by the decimals, convert it to number, and then divide it by the same number of significant digits. So I'm guessing there is a limit to how big the big number library can handle. I'm guessing it's like 256 numbers. Sorry, 256 bits of numbers. So what that does is that it actually makes it a little bit tougher to work with very, very big numbers. For now, let's just reduce this from like 9 to maybe 5, because I feel like 5 significant digits should be enough for us. So let's go back, take a look at it. Yeah, it's attempting to get it, and it got it. Okay, cool. So it's this humongous amount. So it's basically 41 million staked ohms, right? And let's see how much it actually has from the holders tab. If we take a look at the holders tab, let's go here. Actually, no, let's just go back here. It is already the token tracker. I guess I just need to remove that, and then I can go back to holders. Holders, there we go. 41,343,770. So this one, for this one, it works well. But for the account, this first account, it is actually reporting the wrong number, which is weird. So let's try, like, I don't know, maybe the wrapped staked own contract. And let's see. I wish there was like a way to copy the address like directly from there. I have to like go to this new page. Oh, it's okay. Balance page, address. Yeah, let's go back to the address, change it, go back here. Alright, it says 498,902. If we go back to where we were, actually, was it this tab even? 498.902.54. Okay, that's good. So this our code is working pretty fine, and we are able to gather even like very large amounts. That was actually good because it tried the edge cases. For example, what if you have a really big number of some coin? Turns out that my implementation of this contract, my implementation does seem to have some limitations in terms of if the number is like really big. All right, cool. So I think this is pretty useful. I think for getting back to getting the address in AVAX. This is like we're all doing all of this so that we can get the address in AVAX. But in the midst of it, I just want to do a whole bunch of refactoring as well, and that's what I've been doing. So this logic where we get the pair contract and we get the two reserves and divide them by each other, this is also a really useful thing to basically pull out and make it its own kind of utility. So let's go here. I believe we can probably just make a file called TypeScript. I don't know, pair utility, and then we can have a whole bunch of utility functions here, right? So back to balance page. If we take a look at this. All right, so we want the actual contract address. So export const, and then we do get relative price in pair, and then we do ID contract-ish. So it'll be either an address or the ID of the contract. And then we want the base price to be, okay, let's do base contract-ish too. So the idea here is that if I'm, for example, looking at a WETH USDC pool, I want to, for example, put the base as USDC so that I can know how much WETH is, like 1 ETH results to how much USDC. That's kind of the idea, right? So in this case, where we're taking a look at OHM DAI contract, for example, let's do it. Let's do it this way. So pair contract, and then we also have the pair. Let's rename this to pair. Actually, this is a pretty much better name for it, pair. So, and then we do pair contract, maybe. That'll be better. Okay, cool. And then we can basically get the reserves now. Or even better than that, let's get the tokens. So const token 0 equals await pair contract dot token 0. So that gives us the first token. So remember, if we're taking a look at, for example, the OHM DAI pair, there's no guarantee that OHM is first or DAI is first. So we gotta actually figure that out ourselves. So right now we just named them token 0, token 1, and then we're gonna do a direct comparison with the maybe the address. So this is the token 0 address and token 1 address. So let's actually add that here. And then we can do const token 0 is load token, and then we give it the token 0's address. And same we do with token 1. Token 1 address, and let's put await for both of these things because it is asynchronous. All right, so we have both the tokens now. Pretty awesome. And now we do const reserves 0, reserves 1 equals await pair contract dot get reserves. Reserves. There we go. This is super useful. So let's say we have token 0 be OHM and then token 1 be DAI. If we want to see how much, like the base is, I guess, so we want to get the output in DAI. So we want to see like what how much die is 1 ohm worth. So by that we should be like, if reserves 1 is die, we should divide reserves 1 by reserve 0. So const total 0 is token 0 from big number and then reserve 0. And then if we do total 1, we do token 1 from big number, reserves 1. And then let's see, let's say total 1 is the total die that we have. Then in that case, we return total 1, total 1, divide by total 0. And I believe that gives us the thing that we need. The only thing that we need to kind of take a look at is if base equals token 1 address. So if the second one was die, then we return this. So we return total die over total ohm. Else, we return total die over total ohm again, but the order is reversed. So we can actually do that in one line here. Return using a ternary operation. Base triple equals token 1 address, and then we can return this or return this. All right, sick. This should pretty much give us the price that we want. So if we take a look at this, we do this, we take the numbers, we do that, and then we take the rebasing token. So that logic actually we cannot replace right now, but these 3 lines at least we can replace. So const ohm price equals await get relative price in pair, and then we pass in the ohm die pair. And also, this is actually pretty cool because the base should be the address and not necessarily the contract dish. So if I pass in the contract ID, it's not going to work. So let's go to the same kind of logic that we had here, and then let's do const. Actually, let's just rewrite to the same variable. So if type of base is string, we change it to, if it's string, we don't do anything with it. If it is not string and it's an ID, then we look up the address and we write it into the same thing. All right, cool. I think that pretty much fixes everything. And then we do const ohm price equals await get relative contract and pair. Actually, that is pretty good so far. Let's get rid of that. And oh, that's the pair, and we also need the contract ID. Die. Oh, we don't have die here. Oh well. Let's figure it out. So let's maybe, this is annoying. All right, let's take a look at the address book. And we do, actually, why don't I just go on Etherscan? I'm being down here. Die token tracker Etherscan. Boom, easy as that. Token die stablecoin. And now we have that. Let's add die here, die. And then when we come here, we have contract ID dot die. We copy this, paste it over here. Whoops, let's paste it again. Oh, then overwrites to the clipboard every time we paste the word somewhere. Okay, cool. So we have that now. Now that we do have that, we can just do die contract ID die. All right, so ohm price that, and all of that stuff should work pretty well. Console.log ohm price, ohm price. Let's do that, and we can basically come here and figure out the ohm price. Alright, looks like I'm making a mistake here because I feel like the reverse of this, if I do, for example, 1 over this, that should probably give me the correct ohm price. Yeah, that does give me the correct ohm price, which is like 602-ish right now. Oh, looks like it's gone down a little bit. Alright, so let's see, what mistake did I make? So if base is token 1 address, then that means that the total 1 is the total die. And we want to divide the total number of die by the total number of ohm that we have so that we can get how much die per ohm. Base is an address. Token 1 is the address. This is weird. Why is it being like that? Let's just do console.log total 1, total 1, total 0, total 0. Let's take a look at it here. Let's see. Total 1 is this number, total 0 is this number. So total 1 is actually bigger than total 0. And this is exactly what I want. So let's take a look at base 2. Base and then token 1 address. Alright, so base starts with this. Oh, this is actually really cool. It's a big pitfall because some of these addresses might be the same, but if you do direct string comparison, it doesn't work that well because, for example, this B here is uppercase and this B here is lowercase. That's why that comparison is failing. So it's good that I kind of looked at the logic and I didn't just replace the order of these things because that wouldn't have fixed the issue. So what we can do is to do, actually, let's see if I can do it in a more clever way. So every time that we are getting an address, I can probably just get the address in the lowercase. But it doesn't matter because the contract might return like higher uppercase to us anyways. So let's just do 2 lowercase, and then we just do 2 lowercase, 2 lowercase. Thank you so much, WebStorm, for not completing my code. Alright, cool. So it looks like everything is working. If we come down here, well, I should probably remove this 1 over. And yay! We're getting the correct ohm price. Sick! So, now, what do we do with all of this code that we just wrote? That pretty much gives us the ohm price, but here is where it gets really nice because now for AVAX we can do it in 2 lines. We can do G ohm price, get rid of the price and pair, and then we can do G ohm AVAX here. And obviously we should put AVAX here. So what is the wrapped AVAX address? We need to figure out. Let's go back to Snowtrace. Let's make a new tab. Snowtrace G ohm AVAX or WAVAX address. There we go. Put that here. And then we have the contract, read contract. And let's go and figure out token 0 and token 1. Okay, cool. So we've got token 0. This one is governance ohm. Token 1 is wrapped AVAX. So we can take a look at this. Actually, WaveX. Oh, I don't have the contract ID declared. Let's do it here. Awesome. We come back here and put that address over here. And I believe we basically want to know how much WaveX is in 1 ohm, right? So let's go back to our balance page. And we can easily put WaveX here. Alright, so let's just return this for now. But I want to console.log this. And put it here. Put it here. Alright, cool. And we can see that the G-ohm price is somewhere here. Alright, I gotta go. I'll continue after in a bit. I'm gonna come back.